This is AP Calculus section 6.2, some more U substitution problems to take a look at. These will use some of the formulas from the previous page. All right, let's start right here. Tangent 2x minus secant 2x dx. And we have no powers, but we do have something on the inside of the trig function. So let's use that as our U. And U is 2x. So du will be 2 dx. Then when we go to replace out just the u, we will have tangent u minus secant u dx. And dx is what we have to replace out. We can replace that with 1/2 du. That dx I'm replacing with 1/2 du. I'm going to put the du here and take that 1/2 and pull it around front. Now we're all set. We can anti-differentiate this, and using the formulas from page 3, 1/2. The antiderivative of a tangent u is the natural log of the absolute value of secant u minus, and then the antiderivative of a secant u is natural log absolute value secant u plus tangent u plus a c. So that constant that's back here, that actually encompasses the constant from this antiderivative and from this one. And again, pre-calculus coming back, we have these two logarithms in here that are being subtracted. We can combine them into a single log. I don't know why I wrote 1/3 there. I just broke my liquid paper. One half. Oh, it's not liquid paper, is it? It's paper tape. Anyway, we can combine these logs by dividing the arguments. So this is the natural log of absolute value secant u over secant u plus tangent u plus a c. And I'm going to go ahead and distribute this half through and change out this u all at the same time. So we will have 1/2 natural log absolute value secant 2x over secant 2x plus tangent 2x plus 1/2 c, which is just a different c. All right, let's take a look at number 12. Again, no powers here, so we do have something on the inside of the trig function, so let's just start there, very similar to the last one. And this time u will be 3x. And du then is 3 dx. When we substitute out the 3x, we have cosine u plus a 3 over sine u dx. We can trade out this dx with 1/3 du. We do have a problem here because we have a quotient. And just like there is no product rule for integrals, there is no quotient rule for integrals. So we're going to have to rewrite this. What if we look at this and we split apart this fraction as cosine u over sine u plus 3 over sine u du. Now we have 1/3 of the integral of cotangent u plus 3 cosecant u. Oh, now we can handle this. And the antiderivative of cotangent u is the natural log of the absolute value of sine u plus, there's 3 is going to come down, and then the antiderivative of a cosecant is the natural log of absolute value cosecant u minus cotangent u plus c. All right, I'm going to do a couple of things at once here. I'm going to distribute that 1/3 through, and I'm going to replace out this u back with the 3x. So we have 1/3 ln absolute value sine 3x plus 1/3 times this 3 is 1. So we have the natural log absolute value cosecant 3x minus cotangent 3x, and then 1/3 times that c plus just a different c. There's that final answer right there. On this first one, on number 11, I guess I could have boxed off that answer. I'm sorry. All right, look at number 13, please. Number 13 is an a to the u situation where we have 2 to the 5x plus 3. So if we start here, we have to make that 5x plus 3 literally be a u. So that tells us exactly what our u should be. U is 5x plus 3, du is 5dx. We have 2 to the u dx, and then we can replace out that dx with 1/5 du. And now, following the formula from the previous page, this 1/5 comes down, and the antiderivative of a 2 to the u of an a to the u is that a to the u, or 2 to the u, over ln a, which in this case is 2, and then plus a c. Cleaning this up a bit. Excuse me, I had to sneeze. I'm going to change out that u as well. So this is 2 to the 5x plus 3 over 5 ln 2 plus, again, 1/5 times that c is just a different c. And that's it right there. You're done. Although, just be aware, you more than likely would see 5 natural log 2, but you might see natural log of 2 to the 5th, which is 32. So you just do need to be aware of that again for multiple choice. All right, number 14. This is a bit of a tough one, to be perfectly honest, because it's log-based 3s. And calculus really doesn't like log-based 3s. Calculus prefers to have natural logs. So we need to change the base. So let's think about this. Log base 3 of x is the natural log of x divided by the natural log of 3. That's a pre-calculus change of base formula. So now when I rewrite this, we can see the log base 3 of x squared. So that's going to be this, ln x over ln 3 squared. Now all that's supposed to be divided by this x, but rather than divide by that x and have complex fractions, could we write this as times 1 over x dx? We have a little bit more to do before we actually make a u substitution. This ln 3 is a constant. So we are going to pull that ln 3 that's squared outside of this integral, so that we have 1 over ln 3 squared times the integral of ln x squared times 1 over x dx. Nice. Now when you look at this, you should be able to see what to choose for a u, because we have a quantity that is raised to a power. So let's choose u to be ln x. Then du is, the derivative of an ln, 1 over x dx. Substitute out. And we have u squared times, can you see this all at once, that this 1 over x dx is going to be replaced with that du right there. Now do an antiderivative. This constant comes down. The antiderivative of a u squared is 1/3 u cubed plus a c, which is going to be, if I distribute this through, we're going to have u cubed over 3 ln, okay, now you can kind of think about like trig. You could write this as ln squared 3, or you could leave it as ln 3 quantity squared. Either one is fine. Plus, it is a constant though, times that c is just a bigger constant. The last bit then is to trade out that u cubed and write ln x cubed over 3 ln squared 3 plus a c. Now you could, if you want to, write this as ln 3 or ln cubed of x divided by 3 ln squared of 3 plus a c. Either one of these answers is perfectly acceptable. U substitution is very fun, but it does take practice. The more you do, the better you get at choosing what that u is and then being able to follow on through the steps. Thank you very much for joining me.